Okay, so this chapter is chapter 10.3 in your textbook, Analyzing Functions Graphically. The good thing about this chapter is it's comparing functions that we've been talking about all year. So let's take a look at them. So before we talk about domain and range of each one of these functions, I want to talk about what kind of functions they are. So if you look at the first graph, you see that parabola shape. Okay, that parabola shape is a quadratic. Okay, I also know it's a quadratic because I see x squared in the equation. Our middle one makes a v shape. The type of function that makes a v shape would be the absolute value function. Okay, and we see those absolute value bars in the equation. And our last one kind of curves and it makes the shape of a hockey stick where it starts to taper out at the top and then it gradually decreases very rapidly. So this one is an exponential function. Okay, you can tell from the equation because you see an x in the exponent. So now we need to talk about domain and range. And this can be tricky sometimes. So domain is all of our possible x values. So if I'm looking at my quadratic, I see that there are arrows at the end. That tells me that this is going to go down in both directions. So this graph is going to go down and to the left forever, and then it's going to go down and to the right forever. So it's never going to stop. That means that all values in between positive infinity and negative infinity are possible solutions. So we can say all real numbers, or we can make this symbol for all real numbers. Now range is a little different. Range is how far up and how far down our graph goes. So we already know our graph is going to go down forever. So it's going to keep on going down towards negative infinity. But it will not go up forever. Our graph is never going to go above the point that's right here at the top. Okay, so what y value is that? That is negative 2. So all of our y values have to be less than or equal to negative 2. Our absolute value function looks very similar. So I see the arrows going down in both directions. So I know that it's going to include everything between negative and positive infinity, or all real numbers. My range also will never go above negative 2, but there is a value at both of those negative 2's. So we can say y is less than or equal to negative 2. Now our exponential function is a little different. Again, it has arrows that are going left and right. So our domain is all real numbers. Okay, but our range is different with exponential functions. If you remember, exponential functions have asymptotes. That is an imaginary line that the graph is going to get really, really close to, but never touch. And this time we have a horizontal asymptote. Okay, so that is this line right here that it's going to approach, but never actually touch. Okay, it looks like it gets really close here on the left-hand side, but believe me, it will not touch it. So all of our values for y have to be less than negative 2. Okay, but it cannot equal negative 2 because it will never touch. So notice how I did not put the equal to symbol underneath my less than symbol. Okay, do you guys notice how you can find the domain and range from the equations without looking at the graphs? You might have seen a pattern. So if you notice, our range for all three was negative 2, and the constant values in the equations were all negative 2. So that is a clear indication to what your range is going to be. And we'll talk about that a little bit more when we go over our transformations in a few lessons. Now domain is a little different. You have to think about it. Are there any values that you can plug in for x that will make these equations not work out? No. I can add any number I want in for x. I can put positive numbers, negative numbers, fractions, decimals. Every number that I put in for x in any of these three equations will give me some kind of output. So therefore, I have all real numbers for my domain. Okay, now let's talk about minimum and maximum values. So we briefly talked about this before. A maximum point is a high point, A minimum point is a low point. So we have three functions here. Now, before we get into talking about max and min, let's again review what kind of function they are. So f of x, I notice in the equation how it just has an x. There's no x squared, x cubed. It's just an x, so that is a linear function. Now my middle one, g of x, this one has an x in the exponent. So like our last screen, that's going to be an exponential function. And our last one, h of x, has those absolute value bars. So this is an absolute value function. So let's take a look at the graphs and see if we can figure out if they have minimum or maximum points. So here is our linear function. Now, if you notice, it has, again, arrows at both ends. So that means that this is going to go up forever and down forever. So if it continues to always increase and always decrease, there is no minimum or max. So no min, no max, because it's always increasing and decreasing. Let's take a look at our exponential function. Okay, so I see the arrows on the endpoints. Now we did talk about that asymptote that's right here. All right, so it does appear that it's going to approach 4, but it's never going to actually touch 4. But here's where it gets a little tricky. This one actually, again, has no min or max. Because although this side right here is going to keep on increasing, it's going to get closer and closer and closer to 4. It's never actually going to touch 4, but it's still increasing. It's going to keep on getting closer and closer. So it is always increasing and decreasing. Now our last one, the absolute value, we know it's going to go up forever. It's never going to go down forever though. There's actually a bottom point right here that it's never going to go below. So what y value does it not go below? It doesn't go below 2. So since it's on the bottom, this one has a minimum value at the value 2. Okay, and when we're talking about the value, we're talking about the y values. Okay, so let's go ahead and try this one. So this is your chance to pause the video, try these 3, and come back and check your answers. Again, I recommend you go to desmos.com and put these in the calculator. You do not have to put the f of x and g of x and h of x part. Just put in the right-hand side of your equation. All right, so now that you have taken a second to try these ones, our first one, A, is a quadratic. So quadratics could have maximum or minimums. In this case, this one has a minimum at 1. And again, look at your constant. Okay, our second one, this is a square root function. So this one has a minimum at 0. It will never go below 0. And you notice there's no constant there, so that's why it is a 0. Okay, our C value, this one is a cube root function. This one does not have either one. Okay, because our graph kind of goes like this. So it's going to keep on going to the left and right forever. It's going to keep on increasing and keep on decreasing, so it does not have any of them. No minimum, no maximum. Now, when we're talking about our constants, remember when it talks about transformations, we're going to come back to in a couple lessons, but that constant represents your vertical shift. So the first one was shifted 1 up, so the minimum is at 1. The second one wasn't shifted at all, so it has a minimum of 0. So now let's talk about axis of symmetry. Here's the key thing to remember. Only quadratic and absolute value functions have an axis of symmetry. And if you remember from our lessons in class, axis of symmetry is an imaginary line that cuts through the vertex, that cuts the graph in half. Okay, it makes a mirror reflection. So the left side will be a mirror reflection of the right side. Okay, so let's take a look at this function here. I can tell right away it is an absolute value function, so I know there's going to be a axis of symmetry. So let's look at the table first. So the first thing I want to do is I want to look for the vertex. Okay, if you remember in class, we talked about this with parabolas. We're looking for duplicates. So do you see how 2 and 2 line up? 1 and 1 line up. 0 and 0 line up. And there's this value right here in the middle. That's our vertex. Okay, and our axis of symmetry is the x value of our vertex. So where does it cut through? It's going to be an axis of symmetry at x equals -3. If you take a look at the graph, sure enough, our axis of symmetry is x equals -3. Right, you might also remember this from how to find vertex form. So our equation's kind of backwards. But we do have this part is our constant. That's part of it as well. Okay, let's take a look at this one. This one is a quadratic because I see the x function is squared. So quadratic functions have axis symmetry. So we're doing the same thing as we did before. So we're finding our pairs. 1 and 1, 4 and 4, 9 and 9. So our vertex is 2, 0. So the x value of the vertex is 2. So our axis of symmetry is x equals 2. Now I'll warn you, it's not always in the middle. Sometimes they may show you a table that is above or below your vertex. So sometimes you have to actually look for it. Okay, here's our graph. And the vertical line does cut through the value x equals 2. All right. This one is a square root function because I see the square root symbol. So square root functions don't have axis of symmetry. So if you take a look, if you look at the table, there is no repeats there. Okay, so I can see they're all increasing, all my y values. You can also tell from our graph, there's no line that I could draw vertically that's going to make this mirror reflect onto itself. Okay, so go ahead and try these ones. Again, go to desmos.com/calculator, pause your video, come back when you're ready to check your answers. All right, hopefully you figured it out. We talked about this. Only quadratics and absolute value functions have axis symmetry. This one is an exponential. This one is a cube root. So they do not have any axis symmetry. So no axis of symmetry. I think it was a trick question. Okay, now let's talk about end behaviors. This is also something we've talked about before in class. So in this box shows the notation and how we say these end behaviors. This is something that's going to come back to you in Algebra 2. And if you go on to pre-calc or calculus, this will also be used then too. So this is read, as x approaches infinity, the function f of x approaches what? Okay, and then as x approaches -infinity, the function f of x approaches what? And you have to fill in the blanks. So in our graph here, we have a quadratic. And if I look, my x values, as x approaches infinity, remember infinity is this side of the graph. So as my graph moves to the left towards infinity, where are my y values? Remember this f of x is really y. My y values are going to get closer to what? Well, I see there's an arrow, so this is going to keep on going down forever to positive infinity. Sorry, let's see if we can write that again. Okay, so as the x values approach -infinity, what is the function y values going to approach? Well, again, that's the arrow is going to go down to -infinity. And sorry, actually both of these are negative. I apologize. They're both negative because they're heading down. Positive infinity would be up top. Negative infinity would be down the bottom. Okay, so this is an exponential function. Okay, all right, so remember positive infinity, negative infinity, positive infinity, negative infinity. The signs are just like the quadrants. Think about the numbers that are in those quadrants. Okay, so as our graph moves to the left towards positive infinity, what's happening with the y values? My y values are approaching positive infinity. Okay, and for the next one, oh, actually, sorry, again, I'm moving too fast. Take your time with these. The x values, we're looking at the y values. The x values are approaching infinity. The y values, remember the asymptote, it's getting really, really close to what number? It's getting really close to 0. Okay, I was looking at my x values, not my y values. Okay, as our graph moves to the left, so I see it's approaching negative infinity left and right, up and down, this one's going to keep on going towards positive infinity. So you could have a number value for this, or you could have positive or negative infinity. Okay. All right. So here is a cube root function. Okay. As my x values move to the left, my y values are going up towards positive infinity. Okay. And as my graph moves left, my y values are going down towards negative infinity. All right, and again, you would have to write this whole piece, but the left side is always the same. As x approaches infinity, as x approaches negative infinity. That just tells us, are we moving left on the axis or right on the axis? The right side is your fill in the blank part, and that tells us, are we moving up or are we moving down? Okay. All right, here's another try it. So pause your video, check these out, use Desmos if you need it. Okay, I wanted to show you all 3 of these. Okay, we're just going to fill in the blanks. Okay, so our first one, although I just took screenshots from Desmos, you will notice all of them keep on going forever. They don't stop, so we can imagine that there are arrows there. Okay, and you can zoom in and out on your page, and you can see that it keeps on going. There's no point of stopping. Okay, so for our exponential function on the left, as x approaches positive infinity to the left, to the right, our y values are going up to positive infinity. As our graph moves to the left, our y values are getting closer and closer to 0. Okay, because remember, they're not going to go beneath 0. So they're never going to actually touch negative infinity because they're going to approach that asymptote, which is right along the axis. Okay, we have another exponential function in the middle. So we have another asymptote we need to think about. Sorry, that little spike there, but we have an asymptote right here. So as our graph moves to the right towards positive infinity, our y values are getting closer to what? Well, this time it's getting closer to positive 4. Okay, and as the graph moves to the left, our y values are going to go up to infinity. Okay, and the last one is a quadratic. So this one here, as x approaches infinity, our y values are also going up to infinity. As our x goes to negative infinity, our y values are also going up to infinity, but they're both heading in the same direction. So these two things should be the same. All right, so for this section, the classwork is page 429 and 430. You're going to do problems 4 through 7, number 16 and number 17. The exit ticket is number 14 and 15 on those pages. Please turn this one in to me. You can turn it in by email, Google Drive, or Schoology. Okay, make sure that you use Desmos if you need to, and I will see you soon.